Thanks, convener. So I'd like to invite David Peter, who's our Australian panel convener for transmission and distribution equipment.
Thank you very much, Angela. Good morning, everyone. My name is David Peter. I'm convener of the Australian panel AU-A3 that covers transmission and distribution equipment. Our study committee A3 is responsible for theory, development, design, performance, testing, installation, operation and application of equipment, components, equipment and equipment systems applied to both AC and DC systems from distribution to the highest transmission voltage levels. The equipment covered include switching equipment, gas-insulated switchgears, fault current limiters, surge arresters, capacitors, bushings, insulators, instrument transformers, and other equipment not covered under other study committees. Our main areas of interest including innovative design and development of the new technologies for changing network conditions, for example, DC circuit breakers. We focus on environment and sustainability, for example, lower carbon footprint equipment with SF6 alternative gases. The incorporation of intelligence into T&D equipment, for example, point-of-fail control on capacitor banks, reactors, transformers, and transmission lines. Advanced high-accuracy sensors, monitoring, data gathering, and diagnostics of transmission and distribution equipment. We are interested in new and improved testing techniques, reliability assessment, refurbishment, and lifetime management. Also, mitigation methods for overstressing and overloading. The main technical challenges that impact on transmission and distribution equipment include renewable generation, environmental and climate changes, sustainability in the whole life cycle, digitalization and automation, advanced sensors and data analytics, asset management, and condition assessment. Currently, the main trends in transmission and distribution equipment include increase in equipment ratings, for example, ultra-high voltages greater than 800 kV, interconnection of grids and higher fault currents, local generations including solars and wind turbines, also generator circuit breakers. The environmental, including SF6 alternative switchgears and high voltage vacuum equipment. Digitalization, including IC61850 communications, the point-of-fail control, advanced sensors, low power non-conventional instrument transformers, monitoring and condition assessment. High voltage DC switching, including high voltage and medium voltage DC circuit breakers. Fast driving technology, including fault current limitations. Also energy storage, including batteries and converters. Along with decarbonization, one of most interesting topic in Paris was related to SF6 free switchgear products and projects. Now we have vacuum technology moving into higher voltages per single break. We have circuit breakers developed up to 170 kV. The air or CO2 is used as a main or carrier gas for insulation or for interruption. The two most preferable SF6 alternative gases include C4 fluoronitriol or C5 fluoroketon mixed with CO2 or O2. The new alternative gases must have ideally zero or low global warming point and low negative impact to environment. Be gases at the relevant pressure and temperature. Of course, to have excellent dielectric properties and certain other physical parameters to interrupt the currents. Unfortunately, due to increased filling pressure and probably greater dimensions in equipment, retrofilling of SF6 switchgear by alternative gas is not possible unless we do it on GIS, certain GISs, but just GIS sections, not the switching equipment. and gas insulated lines. Currently, there are ongoing developments for voltages greater than 170 kV. We are looking into a gas mixture using for both interruption and insulation. We expect first 420 kV GIS somewhere between 2023 and 25. Vacuum circuit breakers, single break is being developed towards 245 kV voltage level. And most likely for voltages greater than 420, we will need dual interrupter. Our study committee, A3, was very busy in Paris this year. We had extensive group discussion, meeting and update on working groups. One of the most visited workshop was on SF6 alternatives for transmission and distribution substations and their switchgears. This was in conjunction with study committee B3. We also had tutorial on field experience and handling of vacuum switching devices. We had poster sessions on special reports. And finally, we had group discussions and contributions. We had about 51 contributions provided from 52 reports. This year, we had 3 preferential subjects. PS1 was on decentralization of transmission and distribution equipment, PS2 decarbonization, and PS3 digitalization of transmission and distribution equipment. So reports were grouped into 4 areas, such that 18 contributions came from 16 reports related to miscellaneous T&D equipment and systems. 20 contributions were prepared on 18 reports on SF6 alternatives. 6 contributions from 9 reports on asset management, monitoring and diagnostics. And finally, 9 contributions from 9 reports on instrument transformers and digitalization. The study committee A3 future events include a symposium in Muscat, Oman in March 2023, colloquium in Birmingham, May 2023, and a symposium in Cairns in September next year. Currently, there are 9 working groups or joint working groups with target delivery date in later 2022 or beginning of 2023. Unfortunately, due to pandemic, some of these dates are pushed forward to the first quarter of the 2023. The most recently approved working groups include Joint Working Group A3B360 on user guide for non-SF6 gases and gas mixtures in substation with target delivery date 2024. Working Group A347 on a lifetime management of medium voltage indoor switchgears, also completion 2024. And the most recently approved Working Group A348, a 4th SIGRE reliability survey on transmission and distribution equipment with completion in 2025. We had 2 technical brochures delivered this year. The first one is TB871 on current interruption in SF6 free switchgears. This is result of Working Group A341. The second one is TB873 related to design, test and application of HVDC circuit breakers. Both technical brochures are available on eSIGRE and could be downloaded free for members. Considering our Australian A3 panel, we had 2 meetings this year. One was online meeting in July, purposely to talk about Paris 2022 special reports contribution. And most recently, in late October, we had meeting in Brisbane. This was first face-to-face meeting after 3 years of pandemic. And this meeting was also arranged online for those who couldn't attend the meeting. On panel members update, we have 20, actually one more. We have a new panel member from Orecon last week, so 21. Therefore, 4 new and 1 NGN member. On our panel meeting, we review the Paris 2022 sessions, including study committee A3 matters, working groups, activities, and tutorials. We had individual utility and supplier report presentations on equipment failures, SF6 management, maintenance activities, latest advances in equipment spare parts, and management. Very hot topics, probably common for other utilities, is procurement issues, including equipment availability, long lead delivery time, price increase due to high transportation cost, shortage of component. It's all because of COVID-19 influence. We also had a very interesting topical presentation by A3 members, including steps towards decarbonization targets, the SF6 alternatives, and new SF6 free equipment development. We talk about Keynes Symposium, papers contribution, and future working groups involvement. Our key focus areas, including SF6 leak mitigation strategy. This really includes a management of the SF6, considering that most of us stock a lot of SF6 and our equipment is SF6 insulated. So we really have to reduce SF6 emission until new technology comes up. Also, we have transition to SF6 free equipment technology, the medium voltage switchgear lifetime management, and asset management topics, including life cycle cost evaluations, equipment condition monitoring, condition-based maintenance, risk-based assessment management of substation equipment, and end-of-life modeling for regulator expenditure and submission. Currently, our panel members are involved in 5 working groups: A342, 43, 46, 47, and 48. Our panel member, Ankur Maheshwari, is convener of the working group A347 on a lifetime management of medium voltage switchgear. Our Wayne Pepper is study committee A3 special reporter and chair of poster sessions. For future events, we are planning a technical webinar on SF6 alternatives in May 2023. We'll try to bring B3 and D1 together. We are planning annual panel meeting next year in September. Most likely it would be in Keynes prior to Keynes Symposium, so everyone from panel member would have opportunity to attend symposium as well. That's all I have. Thank you very much for your attention.